Ladies and gentlemen, this is Umar Jalal. Welcome to AnyMotion Pro. In this exciting tutorial, we are going to learn how we can do procedural content generation. So, without wasting a second, let's start this tutorial. Begin by navigating to our landscape. To kick off the magic, head to the plugins, search for Procedural Content Generation. Check it and give your level a refreshing restart. Now let's create a new blueprint. Name it whatever you want. For this tutorial, I'll call it BP example. Double click to open your newly created blueprint. In the details panel, click on add component. In the search bar, look for spline and add it to your blueprint. In your spline, notice that there are 2 points. We'll streamline this by deleting the second point. Right click on the spline and access the spline generation panel. Within the panel, select circle, set the number of points to 4 and the radius to 4000. This will establish a circular shape based on these points. Now, navigate through the spline point, select the first point and delete it. In the details panel, check closed loop to seamlessly connect the ends. Click on add and search for PCG, which means procedural content generation. Now, return to the content browser, right click and add PCG graph. Select the PCG graph and return to the blueprint. Click on use selected asset. Head back to the landscape and drag the blueprint onto it. You can now manipulate the points by selecting and dragging them. To add new points, simply right-click. Return to the blueprint and open the PCG graph. At this point, remove the 2 nodes that are not needed. Add get spline data and leave it as self. Produce a spline sampler. Adjust the setting as follows. For the spline sampling method, choose on interior. The next step is press D to debug the spline sampler. Now let's get back to the landscape. Observe that meshes are currently on the spline and not inside it. To address this, check the unbound option. Now the meshes should conform to spline. Access the debug setting and change the scale method to absolute and point scale to 0.5. This will introduce a slight gap between the meshes. You will notice equal density values. Click on interior density fall off and add 2 points. This changes the values. Return to the graph, click on the first point and input desired values. Observe that the center is fully white while the outside is black. Now, let's introduce a new node called density filter. Adjust the lower and upper bounds to fine-tune the density in the desired range. Debug the node to observe how we have successfully filtered the center area. And now we are going to add an attribute noise node to introduce randomness into the mix. Debug it to witness the newfound variability. For further control, include another density filter. Adjust the lower and upper bounds based on your preferences. To streamline the organization, select these 3 nodes and name the group inner area. Now, introduce a transform point node This allows to tweak offset, rotation and scale parameters. Before continuing, add a static mesh spawner. Within the mesh entries, add the static mesh of your choice. For example, I'll use Nordic Mountain. Now observe how we can seamlessly integrate our mesh into the landscape. Now get back to the transform point node. Experiment with the setting like offset, rotation and scale to achieve the desired look. Duplicate these three nodes responsible for the inner area and name the duplicated group outer area. Now quickly connect the outer area nodes to the spline sampler to extend the impact to the outer region. Debug this very quickly and now adjust the values within the density filter to cater to the specific requirements of the outer area. Duplicate the transform point and static mesh spawner nodes to customize the appearance of the outer area as well. Within the static mesh spawner, change the mesh to your preference. For instance, I'll opt for rounded stone. Connect the modified static mesh spawner to observe the small stones which are now present in the outer area. In the very last step, we are going to proceed to alter the transform setting to achieve the desired layout and appearances. Congratulations, you have successfully crafted a dynamic landscape using procedural content generation in Unreal Engine 5 by manipulating the density filters, attribute nodes, and clever transformations. You have shaped the both inner and outer areas, each with its unique character. The addition of carefully chosen static meshes further enhances the realism of your scene. Stay tuned for more Unreal Engine 5 tutorials, and until next time, happy creating.